Hello, my friend. Welcome to my channel. So today I'm going to talk about a hypothesis testing for population mean when sigma is unknown. So let's look at the example. A physician claims that jogger's maximal volume oxygen uptake is greater than average of all adults. A sample of 15 joggers has a mean of 40.6 milliliter per kilogram and standard deviation of 6 milliliter per kilogram. If the average of all adult is 36.7 milliliter per kilogram, is there enough evidence to support the claim at alpha equals 0.05? So as you can see, this is one tail test. Here the claim is the jogger's maximum volume oxygen uptake is greater than. So this is greater than the average of all adults. The average of all adults is over here, which is 36.7 milliliters per kilogram. So let's construct the null hypothesis and the alternative hypothesis. So here the claim is the alternative hypothesis, which is mu greater than 36.7. And the null hypothesis is mu equals 36.7. So as you can see, this is right tail test. Let's look at all the information here. A sample of 15 joggers. So sample size is 15 and sample mean x bar equals, it has mean of 46.6. 40.6. And the sample standard deviation, simple S, is 6 milliliters per kilogram. S is 6. So then let's find the test statistic here. Test statistic. Here we find T naught because as you can see here, sigma is unknown. So we know the sample standard deviation, but we don't know about the population standard deviation. So we can use T scores. So the formula for the test statistic is x bar minus mu over S over square root n. So x bar is 40.6 minus mu value is 36.7 divided by sample standard deviation is 6. Sample size is 15. Square root of 15. So the test value is 2.517. So this is your test statistic value. See, here I'm going to use critical value method and p-value method. Let's look at critical value method. So we are going to make a decision about this test. Under critical value method, we have to look at alpha value. Significant level is 0.05. So as you can see, this is your t distribution and we are in the right tail. So this area is 0.05. So we need this cutoff value. This is your critical value and this is your critical region. And this area is your non-critical region. So let's find the critical value here. You need to find the T table. And to look at the T table, we need the degrees of freedom. Degrees of freedom is sample size minus 1. Sample size is here 15 minus 1, which is 14. So the degrees of freedom is 14. So you look at the first column. So the first column represents the degrees of freedom. So look at 14. And since we are in the one tail, right? Right tail test. So you look at one tail 0.05 here. And then you will see the number over here is 1.761. So this is your critical value. So this critical value is 1.761. So we found our critical value. Now let's look at the p-value method. We need to find the p-value for this test. You know, p-value is the probability of getting extreme test statistic or the sample statistics when the null hypothesis is true. So in this case, we are in the right here. So the t-value greater than t0. Your t0 is the test statistic value, which is 2.517. So we are looking at the extreme cases, right? In t-distribution, you know, we only have the positive values here, t degrees of freedom. So you are going to find two t-values that 2.517 falls between and under 14 degrees of freedom, right? You are going to find two t-values from inside the table. So you will see those two values that 2.517 falls between 2.145 and 2.624. So this 2.517 is between these two numbers, 2.145 and 2.624. And then you have to look at the corresponding alpha value for these two values. So you have to look at one tail. Under one tail, look at the alpha values. You will see for this 2.145, alpha value is 0.025 under one tail test. So 2.624 corresponding alpha value is 0.01. So that means your p-value is between 0.01 and 0.025. Okay, now we found a range for the p-value. We cannot find the exact p-value using this t-table, but if you use a calculator, then you can find exact p-value for this test. But here, since we use the t-table, we only can have a range for the p-value. And let's make the decision. I'm going to use the critical value. I found critical value is 1.761. And I compare my test statistic value 2.517 with my critical value. So as you can see, my test value is greater than my critical value. So that means my test statistic value, so here my cutoff value 1.761 and 2.517 is over here. As you can see, this is the critical region. Your 2.517 is falls in the critical region. So therefore, reject the null. Null is H0. So that's the decision according to critical value method. Let's look at the p-value method. So we compare the p-value with alpha value. Alpha is 0.05. As you can see, 0.01 here, 0.02, 0.25 is over here, and 0.05 is over here. So this range represents the p-value, right? As you can see, your p-value is less than 0.05, right? So therefore, reject the null, reject H0. So now you can write down your conclusion. So our decision is reject the null hypothesis. So therefore, there is enough evidence to support the claim. What is the claim here? The claim that maximum oxygen uptake is greater than 36.7 milliliter per kilogram. So that is the conclusion here. So I hope you understand this problem. If you have any questions or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.